All right, so let's just start with the free response. So if you don't already have g of x typed into your calculator, do that real quick. All right, this is somewhat confusing, and this might be maybe the first time you've seen one problem with two different functions. So f of x is the function that is in the table, and g of x is the algebraic function. They are not related in any way. And so some of these questions are going to ask you about f, and some of these questions are going to ask you about g. And so to do, I think A and B is all about g. All right. And so A wants us to find the zeros as a decimal approximation. So we'll go to the graph. All right, this one has one real zero somewhere, looks like somewhere in between 4 and 5. We have to be accurate to 3 decimal places, so we can't just trace. We actually have to calculate it. Do you guys remember how to do that? Anybody? Awesome. It's second trace, and then we're going to choose a 0. So we want to find a 0, you're going to choose 0. All right, you have this little flashing cursor. I don't know where it is on yours. Mine is on the y-intercept. But we are going to scroll close to that 0 or x-intercept, but we're going to stay on the left side of it, hit enter, and scroll to the other side of the x-axis, sorry, hit enter, and then enter one more time. All right? Now, on my answers, I wrote this lovely sentence. You are welcome to write a lovely sentence on this one, but it's also perfectly acceptable just to write x equals 4.707. If you wanted to go further and say 4.7074, that's fine. 5, it's fine. As long as 7, the third number is the 7, we're good. All right, and then the next question asks where a g of x changes from increasing to decreasing. So I can see that right here. The function is increasing, and then all of a sudden it changes to decreasing. So what do I need to find right there where it changes? What's that called? The maximum. So we go to the same place, second trace. This time we're going to choose number 4. All right, we're going to move that flashing cursor to the left side of the maximum. And then go back over the hill and start going back down the right side of the maximum. And then enter one more time. All right, this one. Negative 1.918.
Sorry, my calculator isn't graphing like yours is.
Okay. All right, let's see if you're zoomed. There you go. All right, and then this third question, you actually had a question almost exactly like this on our first test. Now, it's been a while since we took it. But a ton of people didn't remember this, which just made me kind of sad. But we want to know when this function equals 3. We don't want to know what it equals when x is 3. We want to know what x makes the y equal 3. Any ideas on what we should do? I've told some of you this already. What do you do?
Put the, go back to y and put the second y as 3.
Perfect. Some people do remember. Nice job. All right. All right, so there's one place where those intersect, and that's what we're going to calculate now. So second trace 5. And then we can't just hit enter, enter, enter. Oh, maybe we can't. Just kidding. Try that again. Alright, so let's move close to it. Something weird must have happened in between there. Alright, and then enter. Alright, in this case, you can either round or you can truncate. So that last number could be an 8 or that last number could be 7. Both are perfectly fine.
Wait, it's not working.
Did you move close to it? Did you choose 0 or did you choose intersection? Try it. Go close to it. I did it. It messed up. Okay, let's do this next. Okay, this question is one that there's a good chance if you just look at what your calculator is telling you, you're gonna miss it. So we want to determine the end behavior of G as x decreases without bound. And we're gonna use our answer as a mathematical limit. So you can look at what I wrote with all the pretty sentences, or you can just do the bare minimum, which is perfectly fine. But if x is decreasing without bound, what is x approaching? Yes. Okay, now don't forget that a limit has 4 parts. So you have the part that says limit, you have the x approaches part, you have the function part, and then you have the answer to the limit. If you leave out any of those parts, you don't get this point. And then I did notice yesterday that a lot of people wrote both limits. The limit is x approaches positive infinity and negative infinity. And that is fine, but to get your point, both of those limits have to be correct. If one of them is wrong, even the one they're not asking for is wrong, you don't get the point. So I would recommend you just do the one they asked for. But if you want to do both, you can. It's up to you. So if you're just looking at this graph from negative 10 to 10, it looks like on the left side we're going down, right? That is actually not what's happening on the whole graph. So you have some options. You can zoom out. Now zoom out sometimes doesn't work great. It didn't even zoom out. Oh, there we go. Okay, that's not terrible. Sometimes it gets kind of crazy. So if you zoom out, what is it actually doing on the left?
Going up.
Yeah, that is the answer. So what I recommend, like zoom out maybe will work. Zoom out sometimes isn't great. But what always will work is if you remember this rule about the end behavior, when there's no horizontal asymptote, if you take and you divide the leading term, so you divide x cubed by x, what do you get? If you divide x cubed by x?
X squared.
Yeah. And so this graph at the far left and far right is going to act just like y equals x squared. And what is that graph going to do on the left? It's on the wall. Left and right is pointing up. And so that on the left side of the graph, it is going towards positive infinity. So either way will probably be fine. I like using the formula. I feel like you guys do remember that for the most part. Okay, and so that is pretty much.
So yeah, how do you pick which one's right? Because there was kind of the bottom still going down, and then there was the top one.
Are you talking about the graph?
Yeah.
If you're going to use the graph, you look. If it, as x approaches negative infinity, is as left as you can go. As left as you can go is this point right here. And it's going up. Like I said, I wouldn't do the graph personally. I would look at what I was just talking about. Divide the leading terms is going to act like x squared. We all know x squared looks like this. So on the left side, it's going to point up. Okay, and then I think we're done with G, and the rest of the questions are all about F. All right, and so we're going to determine if F, which is this big table, is best modeled by linear, quadratic, cubic, or quartic. And if you looked at my answer key, I wrote down all the first differences, second differences, third differences, fourth differences, and I recommend that you do that. Not because it's absolutely required, but if you do that, and then your last sentence might leave something out, if it's up there where you actually found it, you still might get your point, if that makes sense. All right, so to make this decision, we're going to start subtracting. We're subtracting one term minus the previous term, or you can figure out like the change. So I'm going to just do that real quick. You're welcome to use your calculator when you do this on your test. All right, so I would start off with my first differences are 2, 4, 30, 104, 250, 492, and that's just taking one and subtracting the previous one. All right, if those were constant, which means they all gave you the same number, then what would this be? Linear. They're not, obviously. So then we go to the second differences. If they were all the same number, it would be quadratic. All right, we'll go to the third differences. If they were all the same number, it'd be cubic. So hopefully these are going to be the same number. We're running out of options. And then we do get 24. So because of that, somewhere we need to write that this is quartic. So like I said, writing out those differences isn't required, but it will help you on the second point if you just don't say everything perfectly right. All right, and then C2. This is the only sentence you absolutely have to write on the free response. There is no getting around it. And so we want to give a reason for our answer based on the relationship between the change in the output values of F and the change in the input values of F. Okay, so do you guys remember how you start this? Go ahead.
The fourth difference is output values.
Nice. The fourth differences in output values. Alright, so here we are. We're talking about how they're changing or whatever. Are the fourth differences changing?
Mm-hmm.
Are they changing?
Oh, no.
They're constant. So the fourth differences in output values are a constant. And tell me what that constant is. Good. Sorry, I'm doing this like I did last year. All right. Now, how are the input values changing?
They're increasing by 1.
Yes. So that is the free response question. It will be very, very much like it. It'll be two different functions, but the wording will be the same. I'm not sure if we'll need to find where it equals 3, but it'll equal something. All right, so any questions on the free response now? Okay, what about multiple choice? Some of those were things we might not have talked about in a while. Multiple choice, anybody?
I didn't.
What? Okay, well let's look at 14 real quick. A lot of people asked me throughout the day yesterday about other ones. 14, I'm not sure if we've done one exactly like this. Okay, so it says the graph of rational function is shown, oh sorry, we need to see that right there. And we want to know which of the following rows in the table could describe the asymptotic behavior at -1 and at 1. Okay, so I'm going to go ahead and draw my vertical asymptote at -1 and at 1. So this first one is saying the limit as x approaches -1 from the left side. So all you have to do is look at your asymptote, look at the left side. On the left side of this asymptote, is it pointing down or up? Down. So we want negative infinity. So that is the only one that has that correct. So the answer should be D. If the one on your test is more difficult, we'll go through each of these. And so then on the right side, so we'll go to the vertical asymptote at -1. The right side is pointing upward, so that should be positive infinity. It is. Right. And then the left side of +1 is pointing upward, so that should be positive infinity. And then the right side of 1 is pointing downward, so that should be negative infinity. So that's what you're looking for. Alright. Any other questions on your multiple choice? That's the one I put a star by. Also put a star by number 7, but a ton of people ask me about number 7. Are you guys okay with the wording on number 7?
Hold on.
So when it says input values, just think x values. The x values are decreasing without bound, which is going to be the left side. And then the output values are the y values. We want to know, what are the y values doing on the left side? What are the y values doing on the right side of this function, polynomial function?
Increasing.
Yeah, so if the leading coefficient is positive, I know the right side is pointing up. And then because this is odd, what would the left side be doing?
Decreasing.
Yeah. So pointing down, we're going to be decreasing without bound. Right. Any other questions? Or any questions? Yes.
Can you go over 13 again,
Yeah.
just
Sure.
to make sure I'm doing it right?
So a lot of people are really worried about this Pascal's triangle thing and asking me if they need to memorize it. You don't need to memorize it. You just need to know how to draw it. And I feel like you do. I hope you do. What are all the outside of the triangle? They're all ones. So I know there's a 1 at the top, there's a 1, and there's a 1. And then there's always going to be a 1 there. To figure out this number, you're going to add those two. So that's going to be a 2, and that's going to be a 1. And then that's going to be a 3. So we're adding 1 and 2 to get 3. And then we're adding 2 and 1 to get 3. And then it'd be 1, 4, 6, 4, 1, 1, 5, 10, 5. Whoops. Just kidding. 2 10s. How do I know when I need to stop for this problem I'm about to do right here? As soon as the second number is a 5, we're good. We're good to go. That's the one we're going to use. Okay. And then we only care about x cubed. And so what we would do is this very first one would be 1 times something x to the 5th. This would be 5 times something x to the 4th, 10 times something x to the 3rd. So that first x power is going to be the 5th power, like the original problem, and then it should go down. This is very easy to mess up because a lot of people want to choose this one, and that is wrong. Don't do it. Don't do it. So I know if I was going to do this expansion, it would be 10x to the 3rd. But then the 2 has to be raised to something. What does the 2 need to be raised to, right? Yeah. And it's because these two need to add to equal that 5. So someone yesterday had this written perfectly, but then kept choosing the wrong answer. They kept choosing B. What did we need to do before we make our choice? Like actually square 2. And that's going to be 4, and that ends up being 40x cubed. Alright, any other questions? Okay, we are going to do a crack the code